Okay, so this is going to be a quick review on square roots and radicals. So the radical symbol looks like this, and it indicates a square root. And so in general, the square root of x squared is going to be equal to x for all real numbers. Now there's a couple of properties of square roots that I want to remind you of. One is the multiplication property of square roots. And what that says is that the square root of a times b is equal to the square root of a times the square root of b. And that's going to be really useful for simplifying radicals. So we'll use that in just a little bit. The division property of square roots is very similar, and it says the square root of a over b is equal to the square root of a over the square root of b. And again, I'll show you how we can use that in just a minute. Now, simplified square root expressions do not have radicals in the denominator. Also, any number remaining under a square root has no perfect square factor other than 0. So if the number under the square root symbol has a perfect square factor, then you can simplify further. So one of the things that you need is you need to know your perfect squares. And so I have a list of them here, and I'm going to write them in really quickly, and I would encourage you to do the same. 1 squared is 1, 2 squared is 4, 9 and 16, 25, 36, 49, 64. This is 81, 100, 121, 144. So everything that I just wrote out is a perfect square. So if you take the square root of that number, you get a whole number. So square root of 64 is 8. If 64 is under the radical sign, then you can simplify it by just taking the square root of 64 and removing it from the radical. Okay, so let me show you how we use all this. Now, here I have the square root of 50. So the question I'm asking is, are there any perfect square factors of 50? So is there anything that you can multiply to get 50 that's a perfect square? And the answer is yes. 25 times 2 is 50. 25 is a perfect square. So we could rewrite this as the square root of 25 times 2. And then we can use the multiplication property. So that would be equal to the square root of 25 times the square root of 2. Now, the square root of 25 is 5. So instead of writing the square root of 25, I can just write 5 times the square root of 2. And that's going to be my answer. That's the most simplified form. Because now under the radical sign, I don't have any perfect squares, or there are no factors of 2 that are perfect squares other than 1. We can check this on our calculator. Okay, you can put in the square root of 50 on your calculator and you'll get like 7.07 and then a bunch of numbers. And you should get the same thing if you put in 5 times the square root of 2. And if you do that, you're going to get 7.07 and then a bunch of the same numbers. So that's your check. If your original expression is equal to the same numerical value as your simplified expression, you did it right. Okay, let's look at B. In B, the issue is you cannot have a radical in the denominator. And so the strategy we're going to use is we're going to multiply by 1 to get that radical out of the denominator. But the way we're going to do it is we're going to write 1 in a certain way. We're going to write it as the square root of 11 over the square root of 11. Any number divided by itself is equal to 1. But when we write it like this, we can get the radical out of the denominator. So I'm going to come down here and say square root of 5 over the square root of 11. And then I'm going to multiply it by the square root of 11 times the square root of 11. And when we multiply fractions, we just go straight across. So I do square root of 5 times the square root of 11. And then I do the square root of 11 times the square root of 11. Now I want to show you something. So if you do the square root of a number times the square root of the same number, your product is just going to be the number under the square root symbol. So the square root of 11 times the square root of 11 is 11. You could try that with anything. So the square root of 1,587 times the square root of 1,587 is the number under the square root symbol. So if I go back here, the square root of 11 times the square root of 11 is just 11. Now, the square root of 5 times the square root of 11 is equal to the square root of 5 times 11, which is equal to square root of 55 over 11. As far as I can tell, there are no perfect square radicals or factors of 55, and so this is going to be our answer. So when you have a radical in the denominator, you're going to multiply by 1. Any number divided by itself is 1, but you're going to write it in a way that you're going to use the denominator radical to make 1. Okay, this we're seeing the same thing. We cannot, for C, we cannot have a radical in the denominator. So we're going to use the same strategy. We're going to multiply by the square root of 15 over the square root of 15. And we end up getting, we can do square root of 3 times square root of 15 is square root of 45. And then square root of 15 times the square root of 15 is 15. But now we have to look, and does 45 have any perfect square factors? And the answer is yes. That's the square root of 9 times 5 over 15, which we can write as the square root of 9 times the square root of 5 over 15. The square root of 9 is 3. So 3 times the square root of 5 over 15. And then the last thing we can do is simplify this fraction. So 3 over 15 is 1 over 5. So we can write this as, you could write the 1, but I'm just going to leave it square root of 5 over 5. So even after you get the radical out of the denominator, you have to make sure there are no perfect square factors of anything under the radical. And so in this case, we had 9 as a factor of 45, and so we have to simplify further. Okay. When you have something like x squared, x to the 6th, or any exponent under a radical, when the exponent is even, you can just divide the exponent by 2. And that'll be your simplified answer. So the square root of x to the 6th is, divide the exponent by 2, it's just x cubed. So if you had the square root of x to the 8th, that's going to be x to the 4th. if you have the square root of x squared, that's x to the first, which is just x. When the exponent is odd, you need to separate out to get an even exponent. So we're going to use the multiplication property here. So if I have the square root of x to the 7th, that's going to be equal to the square root of x to the 6th times x to the 1st, or just x, which we can write as the square root of x to the 6th times the square root of x, which is equal to, remember, x to the square root of x to the 6th is x to the 3rd times the square root of x. So you would do that with any odd exponent, and I can do another one below. If I have the square root of x to the 9th, I would write it as the square root of x to the 8th times x, which is x to the 8th times the square root of x. This would simplify to x to the 4th times the square root of x. Okay, this last one, we can write it out using the division property, so negative 3 to the 4th over the square root of 12. And we can simplify this one at a time. So the square root of anything with an exponent, you can just divide that exponent by 2. So that would be just negative 3 squared. If you substitute an x here, the square root of x to the 4th is x squared. And that's over square root of 12. Negative 3 squared is 9. You can check that in your calculator. Now I can't have a radical in the denominator, so I'm going to multiply by the square root of 12 over 12. Or sorry, square root of 12 over square root of 12. So I get 9 times the square root of 12 over 12. Now there's a bunch of different directions we can go here, but what I'm going to do is, there is a perfect square factor of the square root of 12, or sorry, of 12. So I'm going to do 9 times the square root of 4 times 3 over 12. Square root of 4 is 2. So that's going to get pulled out, and we're going to have to multiply the 2 by the 18. So it becomes 18 times whatever's left over in your radical, so square root of 3 over 12. And then I just need to simplify this fraction. So 18 over 12 simplifies to 3 over 2. And that's my simplified version. So this is making us apply all of the rules that we've just learned. So I'll go through it step by step. So I used the division property. And then I divided exponent by 2. And then I just did 3 squared, or sorry, negative 3 squared. Then I multiplied by 1. Then I found perfect square factor under the radical. And then I simplified the fraction. So it's a lot of steps, but it's just applying what you learned before. Okay, let's do a few more. So I'm asking myself, is there a perfect square factor of 18? And the answer is yes. So that's square root of 9 times the square root of 2, or times 2. So we can write that as, which is 3 times the square root of 2, because I'm just taking the square root of 9. So that would be my answer. Does 75 have a perfect square factor? Yes. It would be square root of 25 times 3. And you don't have to write all these steps if you're seeing it. Okay, this one looks a little bit different, but it's just adding a negative outside the radical. So whatever the answer you get is, you're just going to take the opposite of it. So what we're going to do is take or simplify using the division property. So it's the square root of 7 over the square root of 13. We're going to multiply by 1 to get the radical out of the denominator. And so 7 times 13 is 91 over 13. I don't think there are any perfect square factors of 91. And then just don't forget to bring your negative over and put it in front. Okay. Number 4, we can use the division property. So square root of 8 over the square root of x squared. Now you could do your multiply by 1 to get the radical out of here, but you have a perfect square underneath the radical symbol. So the square root of x squared is x. So you can just write that as square root of 8 over x. Now, you might think you're done. You're not. 8 has a perfect square factor. So that's square root of 4 times 2 over x, which is the square root of 4 times the square root of 2 over x, which is 2 times the square root of, 2 times the square root of 2 over x. Okay, here we have negative square root of 200. So I'm just going to take the square root of 200 out by itself, and I know that there's a perfect square factor of 200, which is 100. Square root of 100 is 10, so I have 10 times the square root of 2, and then I'm just going to bring my negative over. Let's do a few more. Okay, so if it helps you, treat this as x to the 4th. So the square root of x to the 4th is x squared, and then you would just bring your negative over. So we can do the same thing over here. The square root of 10 to the 4th is 10 squared, and then bring our negative over. But here we can compute this. 10 squared is 100, so negative 10 squared is negative 100. So you have to think of it as put the 10 in the parentheses, or the 10 squared in parentheses. So it's the opposite of 10 squared. So you're going to get negative 100. Okay, so we have 120x. So does 120 have any perfect square factors? What I'm thinking of is 30 times 4. So you could do 30 times 4 times x, which is, I'm just going to put the 4 first, square root of 4 times the square root of 30 times the square root of x, which would be 2 times the square root of 30x. Does 30 have any perfect square factors? I don't think so. So I think that would be our most simplified form. Okay, square root of x squared, y squared. Well, we can separate that out and say the square root of x squared times the square root of y squared. Square root of x squared is x. Square root of y squared is y. So that would be our answer. Okay, so this one, we have to see, does square root of 320 have any perfect square factors? And it looks like 64 is a factor. 64 times 5 is 320. So I can write this out as 5 times the square root of 64 times 5, which is equal to 5 times the square root of 64 times the square root of 5. Square root of 64 is 8. So I can write this as 5 times 8 times the square root of 5. And we can simplify even further. 5 times 8 is 40 times the square root of 5. Okay, last one. This one's kind of tough. So when you have two things being multiplied and then you're squaring that, what you can do to simplify this is, I call it distributing the exponent. So this is 2 squared times the square root of 27 squared. So 2 squared times the square root of 27 squared. Remember, if you're squaring a radical, square root of 27 times the square root of 27 is equal to 27. So we can simplify this by just writing it as 27. So 2 squared is 4 times 27, which is 108. And that's our answer. So that was a bunch of different examples. I know that this can be a little bit intimidating and there's a lot of rules, but with practice, you'll get the hang of it.